Hello everybody and welcome back. This will be our last video concerning the 2007 Grade 8 Gauss because we are on the last question, question 25. A rectangular piece of paper, ABCD, is folded so that the edge, CD, lies against edge AD. So that's this picture over here, making a crease DP. It is unfolded and then folded again, but now so that edge AB lies along AD. So what would that look like? We'd have AD, B would be folded up here, and DC would be fine. Most of this would be fine, but we'd have a brand new crease. Okay, and making a second crease, AQ. All right. Then it's unfolded, I guess. The two creases meet at R, what we've got here, forming triangles PQR and ADR as shown. If AB is 5 and AD is 8, the area of quadrilateral DRQC is what? Okay. So we're being asked the area of a quadrilateral. When I look at this quadrilateral, it's not a nice... A nice quadrilateral would be a rectangle, or a square, or a trapezoid. This doesn't even look like a trapezoid. It does have a right angle at DCQ, but I don't think that's really going to help me. So it's an awkward area, and what I find the best thing to do for a question like this is to make that area the difference or sum of a bunch of smaller, nicer areas. So I'll show you what I mean. We'll draw our finished result picture with all the creases. So I got P, Q, R, C, D, A, B. So I noticed that the quadrilateral that I want, so the area of DRQC, is the area of a bigger triangle, DPC, minus a smaller triangle, RPQ. Now this isn't the only way to do it, but it's what I would say is a fairly apparent one. Okay, we want to take the blue triangle and subtract off, let's say, the red triangle. Okay, these triangles I'm suspecting are going to be a little nicer. For example, I can see already our blue triangle is right angled. And I think the red one might be as well, but maybe that's just the way the picture looks. We'll have to investigate that. Okay, so what can we do? Can we figure out what PC is? Can we figure out that length? Well, yes, I think we can. So when we folded it originally, we had D, we had P, C was folded up here. And we can see ABPC is a rectangle. So that tells me CP is AB, but I know AB. It's 5. Okay? In fact, since the original thing we started with, the original sheet of paper was a rectangle, I also know CD is 5. So I can figure out the area of DPC right away. It's 1/2 base times height, which is 1/2 5 times 5. So now I just need the area of RPQ, and I think that's where we're going to have a little bit of work to do. So how can I figure out... okay. So, let's see here. Well, so I know CP and CD, they're the same. They're both 5, right? But we've got a right angle here, and that's going to force these two to be 45-degree angles. So when I unfold it, this angle right here is really just this angle right here. So 45 degrees. And if we look at the other fold that we make, the exact same reasoning tells me I'm going to get another 45 degree angle. Okay, this will be 5. This will also have to be 5 because it's in a rectangle with CD. So we get these two angles both being equal at 45 degrees. So we have a right angle here. So this one here is 45 degrees. So it's isosceles as well. Okay, and that tells me then that we're going to have a right angle here. 45, 45, that's 90. We need another 90 to make a full 180 degrees, right? So we get another 90 degree here. So what are we to do? Well, if I want the area of RPQ, I can say immediately now that that's going to be 1/2 base times height, RQ times RP. I just need to know what those lengths are. And since we do the same thing to both sides, you can, well, actually no, we can see already that they're both the same because we have an isosceles triangle, don't we? Yeah, we do. So if only I knew the distance RP, we'd all be done. We'd be set. Okay, can we figure out the distance RP? Can we figure out the distance RQ? Could we do anything? Well, there's one thing that we can do pretty quickly, and that's figure out what PQ is. Right? We have a total length here, AD of 8. And I know CD is 5. And that leaves with 3 left over. So BP is 3. And in the exact same reasoning, QC is also 3. So we get 3 here, we get 3 here. The whole side is 8. That leaves 2 for here. Okay? So now I need a little bit more space. This doesn't really deserve to get a whole other sheet, but just do a little bit of space here. So if I have 2, and I have a right angle triangle, and both of these sides are the same, let's give the sides the name, x. So this is just 1/2 x times x. Well, by Pythagoras, the Pythagorean theorem, I know x squared plus x squared is equal to 2 squared. Well, that's going to mean 2x squared is equal to 4. Divide by 2, we get x squared is equal to 2. But looky here, that's x squared right there. So this is 1/2. 5 times 5 is 25. Minus 1/2 of 2. So this is going to be 12.5 minus 1/2 of 2, which is 1. So we're going to get a final answer of 11.5 for the area of that quadrilateral that we wanted so long ago. 11.5. I think I saw that as one of the answers. There it is. It's D. So we're going to bubble in D. And that's it. Now, if we were actually doing the contest and we had time left over, one thing you should do is double check some of your answers. Things to double check. The first few questions, yeah, I know you probably breezed through them, but sometimes we look at questions number 1 and 2 and 3 and we think we can do them in our heads, and we probably can. But you're also racing to get question A, the part A questions done, and you can make silly little mistakes. You know, you can add a 5 when you should have added a 4, that sort of thing. So go back and check questions 1, 2, and 3. It shouldn't take you that long. Other things to double check, I would say questions 20, yes, 20 through 25 if you have time. And any questions you were a little unsure of. Now, the reason I include question 20, it's a part B, it's not worth as much as the part C questions. But question 20 can also be fairly challenging. Okay? And again, anything else you either skipped over or were a little unsure of, if you got time, that's when you go back and double check. Okay? Get your answers on the sheet so that if somebody calls time, you hand it in, no worries. But if you have the time, go back and double check anything that made you uneasy. Check the first few questions so you didn't make a stupid mistake. No one wants to get their paper back and find out they got 145 out of 150 because they screwed up question 1A because they were just rushing. Okay? But that's it. That's the 2007 paper. 2007 grade 8 Gauss. If you're looking for the grade 7 Gauss, which should be a little easier, I've already got that up. The next grade 8 Gauss I do will be the 2008 paper. If you're looking for a bit more of a challenge, coming up eventually will be the 2007 Pascal paper, which is aimed at a grade 9 level. But until then, I will see you guys in another math video, and have yourselves a wonderful day.